Hi, this is Poornima Mahalingam, and you're watching video lecture series on solar and wind energy systems. Today, in this video, we are going to discuss about the power quality interconnections, which is navigating the network integrated issues. So, which comes under the unit 4 of solar resources. Come, let's put the Your first part is empathy. What is an empathy? Main causes of this topic. Here is a globally electrical demand increases by 2.2% in 2023. So necessarily significant grid gets expands. So the interconnections is virtual for modernizing the grid and integrating renewable energy sources. Our goal is to enhance the renewability and economic efficiency across the regions. Here comes the implementations. The first one is we have 2.2 percentage of increase of demands, globally electrical demand across the in 2023. So we have 100 percentage clean electricity, the US goal for 2035. And we have three major interconnections. So the interconnecting link, which is distance electrical power grid, it enhances the reliability, enabling economic power exchange and the failures and facilities renewable energy sharing. So global decarbonization goals like the US aims for 100% of clean electricity by 2035, which derives this implementation. So the North American exemplifies with these three major interconnections. So what are the technical challenges we have? These are maintaining technical challenges. One is inertia losses. One is the inertia losses. There's inverter-based renewable lack rotation, inertia implementation, frequency stabilities. The next one is frequency control. So increased renewable variety causes, which is rapid frequency deviation. The next one is voltage stability. So managing reactive power prevention, voltage collapse in weak areas. So reactive power plays a major role. So next one is where the maintaining the grid stability is important. And in 2016, the South Australian blackouts highlights this issue with the high wind penetrating. So what is an operation challenges we are maintaining? Operation challenges. So market integrations, the harmonic diverse market energy market rules the transmission traffic. And here is data exchange. So real-time data sharing across the disparate utility systems and managing the cybersecurity researches. And the third one is regulating what are the hurdles? So diverse states and federal regulations, which is complicating the new transmission distribution developments. Here, the maintaining the grid complexity involves significant operations hurdles, which integrating diverse electric energy markets and transmission traffics in challenges. Real-time data exchange across the disparate utility system, which poses the cybersecurity risks. So here we have in 2018, we address the energy storage market integrations in US RTOs and ISOs. Here we are going to see a small case study. Comes here, it is case study on. So we have our case study in CASO. So our renewable integration success. Here the duck curve challenges. CASO faced peak net load issues from higher solution. It is faced the peak load issues from high solar penetration. So storage solutions, over 5 gigawatts of battery storage developed by 2024. So market strategies, flexible RAM production implements in market strategies. And then last one is reliable outcomes. So managing variable maintenance reliable with high renewable penetrating. So finally, what happens here it is California ISO successfully integrated renewable energy of duck curve. Duck curve challenges where high solar penetrations causes evening peak net load. So their solution of 5 gigawatts of storage capacity batteries by 2024. By implementing the flexible RAM product, CASO managed variable maintenance reliable over 50% of some days. Here the another case study of CASO. Here we have seen what are the challenges is we have challenges Texa installations during extreme cold. So what issue it is insufficient voltages of generator. The third one is impact. What impact is 4.5 million customer cost of $195 billion economic changes. And then what lesson we have learned is near robust extreme weather planning. planting. Here comes the winter storm Uri exposed critical vulnerability, ERCOT's islands grid during extreme cold, insufficient winterization of the natural gas, coal, and wind generations leads to the wind speeds, failures, storms, etc. So we have seen that 4.5 million customers to lost powers. These are the main one of the case studies. Here comes to the solution. So we have advanced grid technology by using battery energy management systems and marketing reforms, and we have an regulating harmonizations and data with AI. These are the some of the solutions we have seen. And here comes that we have a strategic solutions with advanced grid technologies for using battery management systems and RTOs and utilizing data and AI by using the AI. That is an important solutions which focused in real time cognizant purchase. Here comes the conclusions and future goals. So interconnection is the fundamental for a residential sustainable power grid. And the next one is future trends includes high voltage direct current. We have seen the high voltage direct current for long distance transformers and offshore grids, etc. Next comes here it is continuous renewable growth in necessarily greater continuous renewable growth, which is necessarily greater interconnecting collaborations and involves. And finally, by why we are doing this is where it is achieving net zero emission by the main aim is to achieving net zero emission by 2050, hanging on robust interconnecting electrical systems. Here we will be seeing a small recap for this. We are power integrating system. We have so many challenges, optical challenges, strategy solutions, case studies, conclusions. So what is operation challenges, market integrations, data exchange, and regulatory hurdles. These are the operating challenges. And what is the strategy solutions for integration is advanced grid technology. We're using the battery management systems and market reforms and regulating the harmonizations, and by using the data and AI utilizations, will have an solution for the grid integrations problems. I hope you enjoyed this video. We'll meet you next week. Thank you so much for watching.